Hello and welcome to our first lesson in technical drawing. The presentation and the task was prepared by Heilbronn University teacher Andreas Müller. So today we will start with the basics of constructions. Okay, here is just a list with required um, tools for our lessons, but I will show them later. Here is also slides with some information, but we won't pay much attention for it. So we'll start with also here some paper sizes. So one of the important topics here is the scales. So here are some recommended scales and so of course natural scale 1 to 1, and if we see for instance 1 to 5, it's a reduction in size. So the 1 centimeter on the sketch is equal to the 5 centimeters in reality. And it's important that here we can write, for instance, 1 to 3, because it's not the standard which is written here. So we can write 1, 2, 5, 10, 20, and so on. Okay, here are standards also. Here's a title block for drawings. We will write it on the right lower part of our drawing page, but I will again show it later when we will do a task. Here's a parts list, but for easier exercises we won't use it. It's in here time. Okay, here is a more complicated part. So example is this list. Here are some lines designations of German. So one of the most important is the dashed line with dots. So it's like the middle line, and simple dashed line, and also some just some straight continuous lines. Here's also the description. Okay, here are some different representations. We'll use mainly the metric projection, but of course there exists others. So here is the metric projection, where the relation between axes is just 1 to 1 to 1. Here's the metric projection. So the x-axis gets 0.5. Here we have also 1 to 1. But here's a difference with angles in the x alignment. Here's also cabinet projection. So here is the projection method 1, which we mainly use here. German full names, but mainly we will use just abbreviations with 2 letters, such as SR, BS, VA, SL, and DS. Okay, here's information. So in German, it's used more project method 1, but in Great Britain and United States, the projection method 3 is more popular. Here's some information. Individual parts, general drawings, also exploded view. It will be for more hard lessons. Okay. Also pocket caliper. We won't use it also in the near time. Some tools, limit gauge, plug gauge. Okay, here is one of essential rules that there need to be like dimensions must have alignment, so we should place the horizontal number only like here, so we can write it on the bottom or sides, and here it's must be also from it must be written from the left to right in the vertical direction. Also here should be a distinct gap, so between 7 and 10 millimeters, and and some excessive lengths and 1-2 millimeters. And of course, these gaps must be equal in the whole sketch, if it's possible, because some of drawings are quite complicated and there are not a lot of place. Okay, here is a dimension line boundary and arrows. The most important things here is that as the arrows must have an angle approximately 15 degrees. Of course, no one won't measure it, but for correctness, I suppose it's really essential to know, because the two broad arrows are quite a rough mistake in technical drawing, and usually they must be colored as a whole. Okay, here are some dimension entries, examples. In our case, we'll use mainly functional related dimensions. Here is parallel dimensioning. I think it's quite simple. Here's rising dimensioning for a CNC machine. We won't take it till now. Some coordinate dimensioning table. Also, table dimensioning can be used. It's more for a complicated content. Here's some prismatic, cylindrical workpieces. Reduce dimensioning. We'll use it a bit later for surface designations. It's here we can also see the diameter symbol. So 14 millimeters, it's R is radius, so it's quite understandable. Also some diameter dimensions. So some examples. Also for constant countersinks. So these diagonals, sorry. So these diagonals are quite used. And yes, just conform designation. Okay, so next we have indication auxiliary dimension and round brackets. So this information is additional, but the professor suggests not to write it, not to overwhelm the whole sketch. So it's only for help if necessary. Here's some examples of phonetic chambers. You can see here the angle, or we can designate it with arrows, the radius, the inclination, 45 degrees, and the Yes, so that's a diagonal or square sign called also SV, SW. So if here is written SV16, it it states that these diagonals are 16. Each diagonal is 16 millimeters long. So and then and here is also the table with common designations. So quite useful. The diameter. So the square side, so 15 millimeters one side, or each side. The radius, 15 millimeters. The spherical radius, the range size, SR, SV. So spherical radius is SR, and S with this cross circle is the spherical diameter. The thickness, also quite commonly used in the sketches. The H is equal to 5 millimeters. It's a depth or height, and 50 theoretically accurate measurement in the square brackets. In round brackets, as I mentioned, it's an auxiliary or help measurement, and 15 plus minus 0.02. It's a proof mass, okay, and I think, yeah, and also inclination, and stretch the lens in the last row. Here's some tool parts. We won't use it now. Milled parts. Vertical stacking again. Here's three types of cuts. So these are used to make invisible or hidden edge, like holes and drills visible in a technical drawing. So it can be a full cut, half cut, and partial cut. So we mainly use the full cut. Here you think of the front half of the workpiece of being cut out or cut off. Only the back half is drawn. Here is a half section, partial section. It includes the breakout and the partial breakout. Here's the conclusion. Here's a cutting course example, partial view, detailed view. Here we can see the half view, here quarter view. Of course, it's only for symmetrical workpieces. Okay, and here is the new topic, portion sets, but we will review it in the next lesson. So now I suggest we can yeah. Now I will show the task. Okay, here we have German and English. Here how our sketch should look like. And so the task is make a hand sketch of the obtained workpiece. So front side, side view, right, left, top view, and bottom view. But in general, there is a time leakage usually in the exam, so I suggest to draw the part at once, but try to do it accurately. Then measure the workpiece with a ruler and transfer the measurement with your sketch, rounding and measurements appropriately. Use information from your sketch, make a drawing to scale and ready for fabrication of a natural scale, label the views, and enter all known details in the text field or that table what I mentioned in the presentation. Okay, so now I gonna show my solution. Now let's look what we need for technical drawing lessons. So here you can see the Reduce template. Here is the simple version. There is also a more complex, which looks like a spherical thing with a lot of circumference. But they both are good. So then we need graphite pencil with a thickness which can be 0.5 and it should be H. So designate with H symbol. And also we can take the same size with HB designation or type. Also 0.5 millimeters, and here's also filament. Just a typical pencil. This gummy, eraser, the compass. So here some. This is graphic cartridges, or we can also use the pencil itself, just standard pencil. Some rulers. Maybe if you want to use it for angles in the near time. I usually prefer this square ruler, square triangle ruler. And the main thing is the book. So it's a metal table book. It's not the newest version, but still very useful and containing all information necessary. So, for instance, tolerance graphs, surface designations, and also some screws, tables, a lot of, and here's also a formula notebook. Okay, so now let's see our part. I don't have it with me, but I have sketched it just hand. So it looks like this. We have one hole which goes through the part, and two holes which go to the middle part of this detail. They are centered and aligned symmetrically. So in the lesson we just measure it with a ruler and try to sketch it. Okay, and here you can see the solution. So first we need to sketch the basic lines. It's simple. I don't see any purpose to clarify it. So we can just take the part and rotate it in the different sizes, in different directions, different views. So top, bottom, right, left, and front view. Okay, when we have constructed all necessary lines, the holes, we need to put arrows in correct way. So here is only one of possible solutions. We can show the diameter of this central hole, and for upper and lower we can just write 2x and the same diameter and times 5 in depth. So, and here we can see the full cuts. So we have we can designate the hole which goes through the part, goes through completely with a simple dashed line. Hope you can see it. And here it has just a conic form. Also we use in construction dashed line, And these all lines which are dashed with dots, it's just the middle lines, so I use them to align and center all these views and just construct it more easily. And I have colored the solid parts just to see it better. And yes, I told you here are some rules. And and in general that's all. So you can also write the table below with a scale, name, data, paper size, the number in university or company, amount, material, and the name of the part itself. In general, the order here is not so important. Okay, so this time we have done our task quite fastly, and the next topic will be screws and bores. So let's see in several days.